Kirchhoff's laws. The first we'll see the Kirchhoff's current law. In a network, the algebraic sum of the currents meeting at a junction is 0. Now we'll see that what is the meaning of it. Now let us consider there are 4 branches are there and they are meeting at a junction A. This is the junction A. And the first branch, the current I1 is flowing. It is coming to the junctions, and I2 also it is incoming to the junctions, and I3 it is outgoing from the junctions, and I4 it is outgoing from the junctions. Now if we consider that the incoming current to the junctions A to be a positive, and then the outgoing currents are negative, then we find that according to the law, this I1 is incoming, therefore we are taking positive. I2 is also incoming, we are taking it as positive. I3 is outgoing, and I4 is also outgoing, and the algebraic summations of them are 0. That is the meaning of this law. Next, we come to the Kirchhoff's voltage law. In a network, the algebraic sum of the products of currents and resistance in each conductor in a closed path plus the algebraic sum of the EMFs in that path is 0. Now we'll see what is the interpretation of this. Now first you can see here we algebraic sum, that is the algebraic sum of the products. Algebraic sum of the products, that means of current and resistances in each conductors in a closed path. That means I into R, products of I into R in that branch, plus the algebraic sum of the EMFs. Algebraic sum of the EMFs in that path is 0. And we'll take a circuit and we'll understand what is the actually meaning of that. Now let us consider this is the circuit, and one of these is closed path is, this is the B, then we go to C, then D, then E, and again come back to B. That means B, C, D, E, B. In that, we randomly we can take any direction in any branch. We have taken that is of our choose. We have chosen these directions. There is no compulsory to choose in these directions only. And I2 and I3, we have chosen the direction of the current in that branch. And we have in this closed path, we have chosen a direction in a clockwise direction. That is also not mandatory. You can take as anti-clockwise also. Now, after choosing that direction of the current in the branch and in that closed path, you also choose a direction. Then you can see if we come from C to D, there is a resistance. We are coming from C to D, there is a resistance. Now we'll be moving from B, C, D, E, B, because we have chosen the clockwise direction in that path. Now, as we are coming from C to D, we are coming along the direction of the branch current. And in this case, along the direction, we are coming from a higher potential to lower potential. Therefore, the product of I into R2 will be a negative. That is, I am showing here I2 and R2 is negative here. Now you come to the EMF. You can see as we move from C to D, that is a positive terminal and that is a negative terminal. Therefore, we are coming from positive potential to negative potential, then higher potential to lower potential. Therefore, in this case also, the E2 will be the negative. Therefore, E2, you can see here, E2 is negative here. Now we come to this E2B. Now you can see E3, as you go from, this is a negative and that is a positive terminal. Therefore, you are coming from a lower potential to higher potential. Therefore, E3 is positive. And again, in this case, you are coming, as you come from E to B, you are coming against the direction of the current of I3. Therefore, the product of I3 into R3 will be positive. Therefore, I3 into R3 is being shown here positive, and E3 also it is positive, as I told. And therefore, there is no other EMFs and no other IR products in this branch. Therefore, in this branch, in this closed branch, this is the equations. This is the algebraic summation of the product of current and resistances, and the EMF is 0. That is been total. This will get in these equations, and that is all about the Kirchhoff's second law.